Welcome to the lecture series on retrosynthesis. I hope you are following my lectures on retrosynthesis. In my previous lecture, we discussed about how we can synthesize the olefins, that is carbon-carbon double bonds. Friends, there are two strategies for the formation of double bond, that is by addition of water molecule across that double bond or a Wittig reactions. So friends, can you solve the example can you solve this example by using the same strategy? This is a double bond over here, and you need to either you can add the water molecule or you can do the Wittig reaction for this synthesis of this molecule. So friends, let's try to add the water molecule in this double bond. Okay, so there are two possibilities, by either A route or by B route. So friends, the FGI for the A route is not useful for the disconnection as it is near to the CHO group. Okay, so it is not possible to disconnect this carbon and carbon bond. Okay, so if we go for the route B, then this FGI is very helpful for us as we have the OH group on the beta carbon. Okay, if we have beta carbon OH, then we can disconnect like this and we will get the benzaldehyde and the acetaldehyde. So friends, as you know that the reaction of acetaldehyde and benzaldehyde is simple aldol condensation. Okay, so this is how we can go for the beta hydroxy compounds, and after dehydration we get the alpha beta unsaturated carbonyl compounds. So friends, today we are going to discuss about retrosynthesis and synthesis of alpha beta unsaturated carbonyl compounds. Okay, so this lecture is based on the synthesis and retrosynthesis of alpha beta unsaturated carbonyl compounds like this. So in alpha beta unsaturated carbonyl compounds we have double bond, and we are going to apply the same strategies which are we use for the synthesis of olefins. So friends, this molecule we retrosynthesize like this. Now let's see the synthesis of this molecule. So synthesis is very simple. If we have benzaldehyde and if we have acetaldehyde, then we can use a base which will abstract the proton from this alpha carbon and will attack over here. We get the beta hydroxy carbonyl compound. On dehydration, it will give us the alpha beta unsaturated compound, that is our target molecule. Okay, so friends, let's discuss another example. So now this is your target molecule. This is nothing but ethyl cinnamate, and we can prepare it from esterification of cinnamic acid, but still I will ask you to focus on this double bond and how you can make the ethyl cinnamate by retrosynthesis of this double bond. So we have two strategies for this uh, double bond. First, FGI of this double bond by adding water molecule or OH to the beta carbon, and second strategy is disconnection of this double bond by Wittig reaction. So we are going to apply both the strategies, and you will glad to know that in regular organic synthesis these two methods are commonly used for the synthesis of ethyl cinnamate. Okay, so first step is or first method is the FGI of this double bond, that is adding water molecule across this double bond and adding OH at the beta carbon is useful FGI. So it will give us benzaldehyde and ethyl acetate. Okay, so this is the first strategy. By using ethyl acetate and benzaldehyde, we can get this beta hydroxy carbonyl compound. On dehydration, it will give us our target molecule. The second strategy is disconnection by Wittig reaction. As you know that this is a good disconnection, as benzaldehyde is over here and Wittig reagent or phosphorus ylide is another part. So I have this phosphorus ylide. So it can be generated by the treatment of triphenyl phosphate with ethyl bromoacetate, okay, ethyl chloroacetate. These are the commonly used reagent in organic synthesis. Okay, so we get this phosphorus ylide. When we treat it with the benzaldehyde, we will get our target molecule. Let's see the synthesis. Okay, the synthesis, first we learned what the ethyl acetate on treatment with benzaldehyde in presence of sodium and ethanol catalytic amount. So it will generate sodium ethoxide and we will get the sodium ethoxide as a base, which will abstract the alpha proton, and it will generate carbanion, which will attack on the carbon of carbonyl carbon of benzaldehyde, and we will get our target molecule. So friends, most of the time we don't use the sodium hydroxide or potassium hydroxide when we are using this kind of esters, because they might hydrolyze our reagents. Okay, so we are using sodium in ethanol, that is sodium ethoxide. Okay, this is the first method for the generation of this target molecule, and second method is generation of target molecule by using Wittig reaction. So this is how we can generate the target molecule or double bond or alpha beta unsaturated ketone by focusing on the olefin or double bond. Okay, now let's go for the generalization of this alpha beta unsaturated carbonyl compounds. So what we learned for generation of this alpha beta unsaturated carbonyl compound, first strategy is to adding OH2 or water molecule to beta carbon. Okay, OH and beta is very useful FGI. And secondly, disconnection of this double bond by Wittig reaction. We will get aldehyde and either a Wittig reagent or a simple keto compound, alpha hydrogen containing keto compound. Okay, this is the very good strategy for generation of alpha beta unsaturated carbonyl compound. This is general example. Now let's go for the next target molecule. This is very common target molecule in our organic synthesis. So friends, this is our first practical, that is formation of or preparation of chalcone. So let's do the FGI of this chalcone, as we already know how we prepare it, but let's see whether our strategy work here or not. So this is a double bond, this alpha beta unsaturated double bond. What we will do, we will add OH group to the beta carbon, and we will move arrow like this. What we will get, we will get benzaldehyde. Okay, this part is from benzaldehyde, and this part will form acetophenone. Okay, acetophenone. So as you know that how we prepare this chalcone, by treatment of acetophenone and benzaldehyde in presence of NaOH. So friends, this is how we can generate the synthone or synthetic equivalents for the target molecule containing alpha beta unsaturated carbonyl compounds. This is very simple. Whenever you see the double bond, add water molecule across this double bond, or let's think for the Wittig reaction. So if you can prepare this by simple method, why to try Wittig reaction? So you can go for the adding water molecule across this double bond. We will get acetophenone, benzaldehyde, and treatment with NaOH. It will give us chalcone or target molecule. So this is very simple to generate alpha beta unsaturated carbonyl compound. This is our target molecule, and you can see here what I did. This is a alpha carbon, this is a beta carbon. So what I did, added water molecule across this double bond. It will be OH here, and when we move here, we will get this carbon free as CH3, and we get carbonyl over here. Upon treatment with base, it will abstract the proton from here, as is a more acidic proton, and it will attack over here, and we will get OH, and then after dehydration we get our target molecule. So this is how we are going to prepare alpha beta unsaturated carbonyl compound. This is our strategy for the alpha beta unsaturated carbonyl compound. So I have assignment for you guys or homework for you guys. You need to prepare these two molecule by you need to do the retrosynthesis and synthesis of these two molecule as an assignment. I will create it on the Google Classroom. Okay, so this is all about preparation or retrosynthesis and synthesis of alpha beta unsaturated carbonyl compounds. So again, this information I am getting from Designing Organic Synthesis by Stuart Warren and The Logic of Chemical Synthesis by E.J. Corey. These two books are very useful books for the retrosynthesis. So thank you very much. If you have any doubt, feel free to ask me. Thank you.